Hello, Chiban Acharya again. In this video, I'll do the homework from section 6.1. The topic is discrete random variables. Okay. The first question is the definition questions. Question number one. What is random variable? Okay. You might see the definition in my lecture video or PowerPoints or textbook. The answer for this question is C. A random variable is a numerical measures of the outcome of the probability experiment. That's the random variable. Okay, if you read other options, this is not the same as C. Because in the first part A, in this answer choice, it says a numerical measure having a finite or countable number of value. It doesn't have to be finite or countable number of value. Could be infinite value for the random variable is possible. Therefore, this is not the right answer. It is also not right because it says random variable is a numerical measures having values that can be plotted on a line in an uninterrupted fashion. No, if the random variable is discrete, like only having 0, 1, 2, you can plot on the line in uninterrupted fashion. Okay, therefore not always uninterrupted fashion. This is 0, there is no value between here for the random variable. It is possible as well. Therefore, answer B is not correct. Okay. Question number 2. Determine whether the random variable is discrete or continuous. You got to figure out a given random variable is discrete or continuous. In each case, state the possible value of the random variable. You have A and B. A is the number of people with the blood type A in the random sample of 42 people, discrete or continuous. Obviously, number of people here is the discrete variable because number of people count as 0, 1, 2, 3, 4. Okay, look at we are looking for blood type A. That's a subject of interest, and in that group, you can think about 42 people here, 42 people with, and then look for blood type A. Okay, and you might have no people have blood type A, maybe one people have blood type A, maybe two people have blood type A, maybe all 42 people have blood type A. For answer is D. The variable is discrete and the possible value of the variable are 0, 1, 2 up to 42. Okay, and that's how you identify this discrete because of the value of the variable. And now part B, is the weight of the T-bone steak discrete or continuous? Obviously weight is can be measured in the decimal. If weight must be continuous variable, and answer this question is C. The random variable is continuous because possible value of weight gonna be greater than 0. Notice that possible value of weight, which is the variable W, greater than 0. That means any value greater than 0 is possible here for the weight of the steak, right? That's the possible value of the variable. Question number 3. Determine whether the random variable is discrete or continuous. The similar question here, discrete or continuous. In each case, state the possible value of the random variable. This is similar to previous question. Let's answer the question. Is the number of students discrete or continuous? Okay, what do you think? Number of students, of course, this is discrete. And what's the possible value? The possible value going to be 0, 1, 2, 3, 4, and so on. Remember that this doesn't have a finite value, and this is called countably infinite because we don't know where the value ends. That is still discrete because if you plot on the line, it's going to be 0, 1, 2, 3, and so on. Okay, that's the discrete. Part B, is the amount of snow that falls discrete or continuous? Amount of snow. We measure snow in the inches, correct? Therefore, if you measure snow in the inches, inches is the the height or length unit. Okay, um, and in this case the random variable is continuous because the possible value of the inch is going to be x is greater than or equals to 0, because there could be 0 inches snow, right? Therefore this is the continuous variable. In the flight time, accumulated, discrete, or continuous? Of course, here is the time is the variable we're looking for. Time is continuous because time could be measured in the decimal. The answer is going to be B. All right. The random variable is continuous because possible value are greater than or equals to 0, because time could be 0 and bigger than 0. Flight time per day. If the number of points scored, number of points of course has to be discrete. What's the possible value? Either you can score 0 points or 1 points or 2 points and so on, and that's the answer is C. Okay. Now question number 4. What are the two requirements for the discrete probability distribution? The two requirements for the discrete probability distribution: sum of the probability must be 1. That's the first requirement, which is A. Another requirement is probability has to be in between 0 and 1 and including, remember that here, less than equals to, and it could be equals to 1 or it could be equals to 0. That's the tip requirement. Question number 5. Determine whether the distribution is a discrete probability distribution. If not, state why. And the question is, here you have a probability distribution is given. This is the probability distribution, this is the probability distribution, and the question is asking for which one is discrete probability distribution. That's the question. Let's answer, is this A? Is discrete probability distribution, is this A first? And we answer B. Okay. There is two criteria for discrete probability distribution. This is called sum. Sum of the all probability must be 1, and all probability must be in between 0 and 1. And if you check, all the probability here are less than 1, greater than 0, and therefore this criteria met. And other criteria must be sum of the probability must be 1. Remember that this is the probability: 0.31, 0.28, 0.15, 0.06, 0.20. If you add, the sum must be 1. If you add, sum must be 1. Therefore, for the part A, yes, because the sum of the probability is equals to 1 and each probability is between 0 and 1 inclusive, therefore A is discrete probability distribution. But the B, look at the B here. If you add all this probability, what's the sum? If you add all the probability, okay, all the probability, the sum is not equals to 1. You try. Okay, then obviously all probability are between 0 and 1 inclusive here, but the sum is not equals to 1. Therefore, for B, B distribution is no, because sum of the probability is not equals to 1. Answer is D. No, because the sum of the probability is not equals to 1. Add it and let's see. Question: determine the required value of the missing probability to make the distribution of the discrete probability distribution. That means what value of this probability of 4 makes this discrete probability distribution. Notice that the discrete probability distribution must have the sum of the probability must be 1, but if you add this probability, what happens? There's going to be 0.21 plus 0.31 plus 0.29. If you add this, there's going to be 1 0.81. Okay, that's the sum is 0.81. Therefore, to be 1, you subtract 1 minus 0.81, which is going to be 0.19, and this number here in this question mark must be 0.19. That is P of 4. Okay, 19. Question number 7. The following data represent the number of potholes on 35 randomly selected 1 mile stretch of highway around the particular city. Complete the part A through Z. There is a bunch of the question here, A through Z, and this is the random data. Obviously this is the discrete data because number of potholes is discrete, and you see 1 pothole, 4 pothole, and so on. And first you construct the frequency distribution. Okay, and in other words, how many times 1 repeats on the data set. Let's see. Frequency of 1, I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore frequency of 1 is 11. Okay, 11. Similarly, you count frequency of 2, which is going to be 5. Frequency of 3 is 6. Other frequency of 4 is 5. Frequency of 5 is 3. Frequency of 6 is 3. Frequency of 7 is 2. If you add all them total, this total must be what? 35. That's the total frequency, correct? The second part of the question is construct the relative frequency distribution. This is the frequency distribution. Second is relative frequency distribution. And to find the relative frequency distribution, you divide frequency by total number of frequency. That's the relative frequency for each data points here. Let's find the first box here, and notice that you rounded to 2 decimal places in your answer. Frequency of 1, relative frequency of 1 gonna be 1. Let me write down here is 1 divided by, what's the frequency for 1? 11 divided by 35. And if you divide 11 by 35 and round it to 2 decimal places, it's going to be 0.31. Okay. Similarly, you can find the relative frequency of 2. You divide 5 by 35, you get 0.14, 0.14, and 3, frequency 0.17, 0.17. Frequency of 4, relative frequency of 4 gonna be 0.14 because see, you have a same number frequency for 2 and 4, therefore 0.14, and other one is 0.09 and 0.09 for 6, and for 7 relative frequency 0.06. Okay, and again if you add this total, that's going to be 1. And I should tell you this number here, relative frequency, represent the probability. Okay, I should say this relative frequency is probability, and we can call, let's say, P of 1 equals 0.31, P of 2 equals 0.14, and so on and so on. You can see that way. P of 7 equals to 0.06. Okay, now if you add all this relative frequency, the sum must be 1. Does it make sense? Well, pretty much this relative frequency is P of x, and this potholes are x, and this is P of x. That's all frequency, relative frequency P of x, and this is the called discrete probability distribution. Okay, and again you notice that this each decimal points here, 0.31, represent proportion of each potholes. Okay, now second part C, use the results from part B. What percentage of the stretch of highway have 3 potholes? And you can see that for 3 potholes is like 0.17 is proportion, which is going to be 17%. Okay, and part D, which results from using the results from part B, what percentage of the stretch of highway have 5 or more potholes? 5 or more. That means you're adding this number, these three numbers. Okay, these are the 5 or more potholes percentage, and this is 9% plus 9% plus 6%, and which is going to be 24%. And construct the frequency histogram of the data. Frequency histogram of the data. And you notice that you have 1 pothole frequency 11, 2 pothole frequency 5, 3 pothole frequency 6, and so on. The frequency goes down, okay, as number of potholes increases, and therefore in this case this is the right answer. You can see 1 pothole has 11 frequency, 2 pothole has 5 frequency, and so on. You see number of potholes increases, your frequency is going down. Therefore C is the answer. Okay. Also for E, also for F, consider relative frequency histogram. This is the frequency histogram, other is relative frequency histogram. Exactly similar, and the answer is going to be again, this is the C, because the frequency or relative frequency distribution looks similar. Part C, describe the shape of the distribution. Choose the correct answer below. Obviously this is the skew right. Okay, skew right. Question number 8. In the probability distribution to the right, this is the probability distribution of the random variable x. Represent the number of hits a baseball player obtained in a game over the course of season. Complete the part A through F. This x represents number of hit, 0 number of hit, 1 number of hit, up to 5 number of hit, and that's the probability of the particular hit. In other words, this numbers, first number here is P of 0. I should say P of 0 equals 0.1667. Okay, that means the probability of that player hit 0 is 0.1667. And the first question is, verify is this table represent the probability distribution. That's the first question. And as I said, see, this all probability are in between 0 and 1 inclusive, and if you add all this probability, your sum is 1. Okay, you do it by yourself, and that's why this is the discrete probability distribution. And you answer the question this. This is the discrete probability distribution because all the probability are between 0 and 1 inclusive, and sum of the probability is 1. Okay, that's the answer. And which one is the correct graph for this discrete probability distribution? That's part B. Draw a graph of the probability distribution. Describe the shape of the distribution. And in this question, if you look carefully, for 0 you have 0.1667. Therefore I should say this looks like for 0 0.1667 here. For 1, 0.3355, 0.1 for 1 0.3355. For therefore this is the C. I can easily see from this graph matching with this table, this is the correct distribution. And remember that only one has the highest frequency or relative frequency, therefore the mode is 1, and we call this distribution has one mode. Okay, this distribution, first you describe the shape of the distribution, I guess, or shape of the distribution, right? And you write this, the distribution has one mode, and the shape is going to be skewed right. I can see that. like this, skew right. Okay, makes sense. Now for C is compute and interpret. There is two parts. Compute and interpret the mean of the random variable x. Here's the thing: the mean of the random variable, mean of the random variable x. Okay, the symbol for that is mu of x. That's why it's here, mu of x. And to find the mean of the random variable, how you do it? There's two ways to do it. One way you can use calculator. Another way you can use just formula. I use a calculator, but I'll mention how do you use a formula or what to do to find the mean. To find the mean of the discrete random variable, you multiply the probability and the random variable value. In other words, multiply 0 times 0.1667, 1 times 0.3355, and you add all the product after you multiply. That's how you find without using calculator. But I want to teach you how to find this using calculator. Okay, first you open the data. First the calculator, and always you start number one, edit. And since you have two data, you got to put x and p of x. I says clear L1. I want to clear L2. Now my L1, L2 clear. Now I'm going to put x, or value of the random variable, in L1, which is 0, 0, 1, 2, 3, 4, 5. And I'm going to put probability in L2, which is p of x. I'll be back after putting the data in the calculator, and I'll show you. Okay. Okay, I put the data in the calculator here. You see over here, this is L1, x in L1, probability of x in L2. Okay, and this x in here, p of x in here. Now to find the mean of the discrete random variable mu of x, what you have to do is you just go to start and do number start calc and number 1. Okay, but you say 1 over stat, and here since you type data into 2 column, and you have to type L1 comma L2 here. To do that, I press second here, and I press 1, gives you L1, and comma is here above 7, and I press second, and 2 gives me L2. I have 1 stat L1 comma L2 now, and I do enter, then you'll get this. That's, it doesn't say mu of x here. Okay, that's the mean, and same as this mean here you can see in the calculator. And it's a type the integer or decimal, do not round, you're typing all 1.6316 everything here, 1.6313. okay, let's type here 1.6313. let me see, 16316, sorry, it was 16. That's the mean of the random variable x. This is mu of x, but the calculator just gives you regular mean as a symbols, but pretty much this is mu of x. Next question, interpret the mean of the random variable x. Okay, and to interpret the mean, you have to read all the options here and find the correct answer. You might have to watch the lecture video. The answer is going to be D. Okay, over the course of many game, one would expect that mean number of hit per game to be mean of the random variable. Okay, that's the interpretation. For D, compute the standard deviation of the random variable x. We already found the mean of the random variable, which is this number. Now also question asks you find the standard deviation of the random variable. Standard deviation of the random variable symbol is sigma of x. You can see that this is the sigma x, gonna be standard deviation random variable. To find that, we just use the calculator. We already have this summary in the calculator. You can see that this number here, this sigma x here, obviously you see that that's what it is. Standard deviation of the discrete random variable, which is 1.181. If you round it to 3 decimal places, 1.181. 1.181. That's the answer. 1.181. Part A. What's the probability that the randomly selected game the player got 2 hit? Here you're looking for P of 2. P of 2 is 0.2859. That's the answer. P of 2 is 0.2859. 0.2859. This is same as P of 2. Okay. Part F. What is the probability that the randomly selected game the player get more than 1 hit? The more than one hit, you're looking for 2 hit, 3 hit, 4 hit, and 5 hit. In other words, you are find the probability of 2 hit, 3 hit, 4 hit, and 5 hit, and you add all the probability and you get the total, which is gonna be 0.4978. That's the answer. That's all. Question number 8. Okay. Question number 9. The following data represent the number of games played in each series of an annual tournament from 1923 to 2019, and you see that X is the number of game played and frequency, how often the game played. Okay. And you have this data here, and the question is construct the discrete probability distribution for the random variable X. Okay, here random variable is number of game played. That's the random variable. To find this discrete probability distribution for the random variable X, you got to find P of X. This P of X is same as relative frequency. Okay. To find the relative frequency, you got to find the total number of frequency. Therefore, let's add this total number of frequency. You get 96. Okay, this equals 96 when you add it. Now, to find the frequency for 4, which is X value, you divide 18 by 96. Let me put down here 18 by 96. Okay, and that's how you find the relative frequency, which is also probability for X, and rounded to 4 decimal places. If we divide 18 by 96, you get 0.1875. Similarly, you do for relative frequency for 5 games, you divide 19 by 96, and you get 0. Let me put down here 0.1875. The other one goes 0.1979. Other one is 0.1979. Other going to be 0.4167. Okay, and this is the discrete probability distribution, because if you add all this probability, sum going to be 1, and every probability is between 0 and 1 inclusive. And if you look at the graph must be I think if you check this, the same frequency, relative frequency. Therefore, this must be this too, and this is a little bit smaller because this is 0.1979. This is 0.1875, and this is the right answer. Okay, you can see obviously from the table that this graph match this table. Okay, now let's answer the question. Compute and interpret the mean of the random variable X. Mean and the random variable X. And to do that, you got to put this data in L1, this data in L1, and this data in L2. Okay, let me put that and back to you. Okay, I put this data in the calculator, and to find the mean of the random variable, and also you got to find the standard deviation. Look at here, and you do both at the same time. Then to find the mean of this and the standard deviation, let's do start calc number 1, and you see one word stat, and type L1 comma L2 here. To find L1, you just type second and 1, that's the L1, put the comma which is here above 7, and do the same thing, second and 2 gives you L2, and you see that's the mean. Therefore the mean of the random variable is 5.84. You round it to one decimal, it's going to be 5.8. And if you look at the standard deviation, you see that 1.157, but if you round it to one decimal places, standard deviation is going to be 1.2. Okay, let me put that answer here. Mean going to be 5.8. When you round it to one decimal, standard deviation going to be 1.2. All right, now next question, interpret the mean. To interpret that, you got to read the question carefully, or the option, and this is the answer. In the series, if played many times, we would expect to last at least 5.8 games on average. Okay, that's the answer. And this is not correct. It says if played one time. The mean of the random variable is if you repeat the experiment often and often, many times. So correct answer is B. Alright, question number 10. Similar to the previous questions, you have a graph, and you can read the graph and you answer the questions, and say find the probability. Find the probability. What is the probability? Therefore, to find the probability, you guys see probability in this vertical axis and number of live births in horizontal axis, and there is already probability is given on the top of each bar. You can read it properly, and we just write the answer here, right? That's not difficult. Question number 11. Okay, and here you see that this is the game. The pointer can land on its shown in the table. Compute the expected value. Here the question is find the expected value, and I want to point out this all question after 11 is find expected value. Okay, you can see that. Other one called find expected value. The other one is called let's just say expected value. Okay, so for every question is about expected value. Alright, here expected value is also same as mean of the discrete random variable. Okay, and I should say expected value is same as mu of x. Therefore, the way you found mu of x, the same way you can find expected value. Okay, alright, and to find the mu of x, you need two things. You need outcome, that's the x, the probability, that's the p of x. Okay, and outcome is x here, and probability of each outcome is given in the on the other column. You can see that. And expected value gonna be, you can put this in the calculator. You can put L1 x in L1, p of x in L2, and you find as we did in previous question. But here you can do directly. Alright, without calculator. Of course you can use to add, subtract, but we don't use calculator function. I should say e of x is the expected value, right? Expected value. You multiply outcome with the probability. 1 times half plus 2 times 1/4 plus 3 times 1/4. Okay? In other words, if you multiply outcome and the probability and add them together, see that? You multiply each outcome with its respective probability and add them. And if you do that, that's simple calculation here. 1 over 2 plus 2 over 4 plus 3 over 4. Let's make a same denominator. Multiply by 2. You get 4 in the denominator. You get 2 plus 2 plus 3 is 7 over 4. That's the answer. And the instructions say rounded to, now it doesn't say rounded, it's the exact answer, type integer or decimal. If we don't use a fraction, and the decimal is going to be 1.75. That's the expected value. Okay. Question number 12. This is the about insurance policy, and you have to read the question, I think maybe a few times to get the idea what the question was saying. Suppose a life insurance company sells $250,000 1-year life insurance policy to a 20 years old female for 310. Okay, I remember that this 310 is premium for a year. According to the National Bureau of Statistics, the probability that the female survive this year is this. You can see the probability of survive is this much. Okay, compute and interpret. There's two questions. The expected value of this policy to the insurance company. You notice that you got to find the expected value to the insurance company for this policy. Okay, again, to find the expected value, what do you have to do? You got to find the outcome and the probability, and you have to multiply. You notice that's how you do. You need to find the outcome and the probability, and you multiply and add. That's how you find the expected value. Okay, unlike these questions 11, question 12 doesn't have a table. Therefore, let's make a table. Here, let's make a table for x and phi of x. Okay, alright, there is two possibilities. If the person survive, what happens? The insurance company get $310, right? That's what I said, because that's the cost of the policy. Therefore, I should say, if let me write down here. There's two outcomes. Survive. What happens? Survive. Insurance company get $310, right? But what's the chance of survive? 0.9999544. Of course, this is almost 1 because 20 years old female survival probability is very high, right? Okay, what's the other outcome? If not survive, let's say die. What's the probability of dying? Remember that survive is complement of die. If we put 1 minus 0.999544, if you subtract, you get 0.000456. This is the probability of not survive. This is the probability of survive. Okay, if the policyholder die, if this 20 years old female die, what happens? Insurance need to pay back to the person. How much? Since 310 is already collected from the policyholder, that many. Okay, you subtract that 250,000 minus 310. Remember that if the person die, insurance has to pay $350,000. But insurance already collected $310. Actually, there is a if you subtract, you get $249,690 minus. Remember that it's a negative. Must be negative for the insurance company. Why? Because insurance company loses that much money when the person die. Does that make sense? Now we have X P of X. You have X P of X. You multiply and add them. That's the expected value. Let me do that for you. Expected value E of X equals to $310 times, I don't want to write the dollar right now, 0.999544 plus negative 249,690 times 0.000456. Okay, you can do that in the calculator. Like, let me put down here directly to find the answer. Let's do that. 310 times 0.999544 plus negative here 249 690 times 0.000456. Okay, enter 196. For this whole thing simplifies to 196. That's the expected value. Therefore, in this question, expected value is 196. And let's interpret that 196. That means, remember, the expected value is the average in the long term. Okay, and you have a bunch of options, you got to choose it. You read it properly, and the answer is C. The insurance company expect to make a profit of $196. This is because it's a positive number. Expected value is a positive number. Therefore, insurance company expected to make this much money on every 20 years old female it insure for a year. Okay, that's the answer, Patrol. Question number 13. In the game of roulette, a player can place a $5 bet on the number 31 and have a 1 over 38 probability of winning. Okay, remember that if the chance of winning in that game is 1 over 38. Okay, and here the person bet $5. There's two things happen. If the person win or lose, that's what happens. There's two outcome. What two outcome? Let's put the outcome here. Win or lose. Lose, L-O-S-E, lose. Okay. Okay. How much person win? How much person lose? That's going to be X. And what's the probability of winning and losing? That's going to be phi of X. Okay. Let's see the question. If the medal land on the ball 31, the player gets to keep $5 paid to play the game. Remember that there's a $5 charge to play the game. Okay, but if player win, player can keep that $5. Okay, and awarded $175. Make sense? Otherwise, the player awarded nothing, and the casino takes the player $5. What is the expected value to the game to the player? Looking for expected value of the game to the player. Okay, if the player wins how much? $175. What's the probability? 1 over 38. If the player loses, how much you're gonna lose? $5. Notice that I put the -5 because that's what you're gonna lose. And what's the chance of losing? 1 minus 1 over 38, same as 37 over 38. Now you see x p of x p of x. You multiply and add to find the expected value. Let's do that. Expected value gonna be 175 times 1 over 38 plus negative 5 times 37 over 38. Use a calculator like I did before. This gives you negative 0.2631. I should say 2631 is still 6 here, up to 5 decimal. But if you write the answer for expected value, it's going to be negative 0.26 only near the cent. Okay, that means in one game the player expect to lose 626 cents. And next question, if you played the game 1,000 times, how much would you expect to lose? Of course, the chance of losing is 26 cents per game. Therefore, if you play 1,000 times, you expect to lose, multiply by 1,000. This number gives you 263.16, this much. Okay, therefore you multiply this expected value by 1,000. That's what you get. That much expected to lose if you play the game 1,000 times. I put the answer here, 263.16. And again, you see, rounded to the nearest cent. That's what we did. That much expected to lose if the player played 1,000 times. Don't put the negative here because expected to lose. Say lose already there, therefore this much expected to lose. Okay, last question of this section, question 14. An architect is considering bidding for a design for a new museum. The cost of drawing plan for the submitting model is 12,000. Remember that this is the cost to submit the model. The probability of being awarded is just 0.1, like 10% chance that then architect gonna be awarded, right? If the architect is awarded the bid, she will make 120,000. Remember that, minus 12,000 cost of the plan and model. Therefore, here's a two scenario here. Either she gonna win the bid or not. Let's say, let's make a table. There's two outcome, x and p of x. I'm sorry, there's two outcome, either win the bid or lose the bid. Okay, if she win the bid, what's she gonna win? 1 2 0 0 0 0 minus 12,000. You know what I'm saying? Yeah, because see here, the probability of being awarded the bid is 0.1, and if she's awarded, she will make 120,000 minus 12,000, which is the cost for the plan and model. Subtract, this gives you 108,000. That is the x outcome when she win, and the chance of winning outcome that much is 0.10. Okay, 0.1, which is same as 0.10. But what's the chance of losing? 0.90. Remember that this 0.10 is 10%, 0.90 is 90% chance of losing. And if she lose, she will lose $12,000. That's the cost of the drawing plan. She will lose $12,000. Make sense? Therefore, you have the probability, outcome, as you say, the outcome and the probability, and the outcome probability, and you multiply and add to find the expected value, and you're gonna get 108,000 times times 0.10 plus negative 12,000 times 0.90. If you do calculation using calculator, you get 0. Therefore, expected value is 0. What do you mean by that? That means in the long run, the architect would expect to break even. The break even means neither profit nor lost. Okay, that's called break even. Alright, that's all about this homework from section 6.1. Thank you for watching.